So far we discussed some important concepts from the chapter 9th standard matter in our surroundings. Shall we summarize in point wise one by one what we have discussed? Very important points shall we discuss now?
Absolutely. Let's summarize some key points. We discussed how matter can change states, the effect of pressure on these states, and evaporation. Then we delved into factors like surface area, temperature, humidity, and wind speed affecting evaporation. We also explored some real life examples. What other important points do you remember?
Then we are already discussed some concepts like physical nature of matter. In previous video we discussed that one. Physical nature of matter. Matter is made up of particles. How small are these particles of matter? Characteristics of particles of matter, and so many concepts we discussed, that is states of matter. I think you've forgotten those one.
My apologies. You're absolutely right. We did discuss those important concepts previously, including the physical nature of matter, that matter is made up of particles, their small size, and the characteristics of these particles. We also touched upon the states of matter. Thank you for reminding me. Would you like to add any other points to our summary?
There is a point more to know in our textbook, that is the point is given plasma.
That's a great addition. Plasma is the fourth state of matter, a superheated state consisting of ionized gas. Bose-Einstein condensate is the fifth state formed at extremely low temperatures. Would you like to know more about these? Okay, so plasma is a state of matter consisting of ionized gas, where electrons are stripped away from atoms, creating a mixture of free electrons and positively charged ions. It's typically found in extreme conditions, like stars and lightning. On the other hand, Bose-Einstein condensate is formed when a gas of bosons is cooled to near absolute zero, causing the atoms to behave like a single quantum object. Are there any specific points you'd like to explore further?
There is no specific questions to discuss.
Alright, so we've covered a lot of ground today. Do you have any other general thoughts or points you'd like to bring up?
Yes. Give two reasons to justify. One by one you have to answer for these questions. First one is water at room temperature is a liquid. Then second one I will tell you after giving the answer for this question.
Certainly. Water at room temperature is a liquid because its melting point is below room temperature and its boiling point is above room temperature. Also, water has a definite volume but not a fixed shape, which is a characteristic of liquids. What's the second point you wanted to discuss?
Second one is an iron almirah is a solid at room temperature.
Yes, an iron almirah is a solid at room temperature because its melting point is much higher than room temperature and it has a definite shape and volume, which are characteristics of solids. Would you like to discuss any more points?
Exercise questions we are discussing 9th standard. What produces more severe burns, boiling water or a steam?
Steam produces more severe burns than boiling water. This is because steam has additional energy in the form of latent heat of vaporization, which is not present in boiling water. So when steam condenses on your body, it releases this extra energy, causing a more severe burn. Do you have any other questions?
Give reasons for the following observations. We have two questions. One by one we can discuss.
Alright, let's take those questions one by one. What's the first one?
Naphthalene balls disappear with time without leaving any solid.
Naphthalene balls disappear with time without leaving any solid behind because they undergo the process of sublimation. This means they directly convert from the solid to the gaseous state without passing through the liquid state. Would you like to know more about this process, or should we move on to the next question? So, sublimation is basically the process of a solid turning directly into a gas without becoming a liquid first. A common example is dry ice, which is solid carbon dioxide. It also happens with air fresheners or camphor, which go directly from solid to gas. Do you want to know the science behind it, or is the explanation clear so far?
What is the science behind this?
The science behind sublimation is that some solids, like naphthalene, have particles that have enough energy to escape from the solid surface and become a gas, even below their melting point. This happens because the intermolecular forces of attraction between the particles are not strong enough to hold them in a liquid state. Does that make sense?
Yes.
Alright, let's move on to the second question. What's the second point?
We can get the smell of perfume sitting several meters away.
That's a good question. We can smell perfume from several meters away because its particles mix with the air and diffuse quickly. This allows them to reach our nose even when we are not close to the source. Would you like to know more about diffusion?
Okay, thank you. Thank you for giving some very good explanation and the concept.
You are very welcome. I'm glad we could discuss these concepts in detail. If you have any more questions later, don't hesitate to ask. Happy learning.